So office hours as usual, although I would ask, does Emma still hold office hours? Or because I know that Emma got a new job. So hello, Emma.
Hi. Um,
Good evening.
Congratulations.
Thank you.
Congratulations on the new job.
Thank you. So definitely this week I will have office hours, and then I think the
Okay.
week after I'm gonna have to play it by ear kind of.
Okay.
I'm planning to still have office hours, but maybe earlier. And Vicky was also talking about taking over my office hours.
Cool. Okay. Excellent. So week 15, today we're going to talk about sets and search engines. And sets is something which I actually added once I started thinking about this week's assignment, and I suddenly realized the first thing is that the assignment is nicely solved by using sets, and second, that sets aren't even discussed in CS 106 for some reason. I don't know why. So I decided to change that and actually include sets as a topic of discussion. And then the last 2 weeks, I suppose, we'll talk about object-oriented programming, or OOP for short. 2 weeks are not going to do justice to the topic because it's a huge separate topic, but at least we'll try to cover the basics and, sort of get our feet wet in this topic. And we're planning to be done by the end of October. Vicky also posted a number of problems that you can try to solve yourselves after we're done with the entirety of our program. There are, I believe, 20 or 21 problems, and if we still have office hour support at the moment, you would be able to discuss it. If you have any issues with those specific problems, Dieter and maybe Emma, who will play it by the ear, maybe will be able to help you out. So thanks for that once again. And as usual, before we go on to today's topic, there is a quiz. And once again, it's going to be an image from a location, and you only have to answer two questions. Nothing fancy. You just have to tell what's the city and what's the country. And Vicky seems to think that this one is supposed to be easy. I'm not so sure, so we'll find out in the next 30 seconds. Vicky, do we still have the t-shirt up for
Oh,
grabs?
sure. I mean, the US economy is just hopping, as you can see by the stock market.
But what about the China tariffs and the war with China right now on the tariffs? I thought that actually sent the markets crashing, no? A bit.
It did, but I didn't realize the markets were up, were open today because I thought it was Columbus Day and the markets were down. But the markets recovered. And so, like the Russian economy, the US economy is strong, okay? You can beat us down, but you can't kill us.
There we go. That's the way it goes.
I'm sure you probably thought that the hostage exchange would be unsuccessful, but actually, to my surprise, Hamas actually released the hostages. And our dear leader is taking all the credit for them. Oh my
Of
God.
course. It's too bad it's a bit late for the Nobel Peace Prize, because
Exactly.
otherwise
You
I'm
took the words
sure
right out of my mouth. Oh my God. I mean,
I'm
that's
sure otherwise
exactly
he
what
would
I
be
was
that
thinking. He's
person
probably gonna be like lobbying
cheering
for
out
the
his
Nobel
hair.
Peace Prize.
Okay, maybe next year. Maybe, who knows? Maybe next year. Fingers crossed for Mr. Trump. Anyway,
Sorry,
anyway.
but the winner called Donald Trump and said, "I accepted, I accepted the prize in your place because you really deserved it,"
Right. Well,
according to YouTube. Yes, there we go.
if you believe Trump, that's exactly what happened, and we know Trump never lies. So, I mean, that's the
I'm just
truth.
curious because I did not see who actually won the Nobel Peace Prize this year.
It's a lady. from Venezuela. I don't remember her name.
From where?
Just from Venezuela.
Venezuela,
Oh,
the
oh,
opposition leader
oh.
of
Venezuela, sorry.
Venezuela,
For what?
for standing up to Maduro.
Oh. Hmm. I mean,
Okay,
since
so
I stand up to Alex, can I win the Nobel Peace Prize too?
yes, you can. You absolutely can, Vicky. I mean, if you need my vote, both hands. Vicky gets
I
the.
don't think you can vote, but that's okay.
What do you mean I can't vote? I'm at least 18 years old, so
No,
maybe
I mean,
slightly more.
in order to vote for the Nobel Prize, you actually need to be invited. So,
Oh, I'm sorry, I didn't know that. So yeah, I thought I just had to have my last name as Noble. That would be enough. Anyway, quiz. Please look at the image on the screen. So, and your guess what city this is and what country this is. Consider that Vicky thinks that this one should be easy.
okay, next week will be really easy because that will probably be the last official one. So I'll make it very iconic and very easy. And no, it's not going to be the White House. Okay. Enough
Okay.
political commentary. So, we're all on official air.
There we go. Sarah is the first one to correctly guess it. It is actually Yerevan, which is the capital of Armenia. And this is one of the popular landmarks in the city. It's called the Cascade for obvious reasons. It's close to the center of the city. I do enjoy walking there from time to time, especially when the weather is sunny. So space, and as you can also see, it's sort of an open air art exhibit because there is a number of art pieces around this location. So Sarah got the correct answer. Congratulations. Once again, you can discuss with Vicky whether you want the t-shirt or you do not want the t-shirt and you want something else. As far as I remember, usually it's Amazon certificates, but what do I know? Anna, you're actually also correct. You wrote Cascade Complex, Yerevan, but you were slightly behind Sarah, but you are absolutely correct as well. Yeah. And I think Yerevan can be, actually, it can be spelled without the Y. I mean, in the original Armenian spelling, there is no Y per se. It's added in English to add the Y, but in Armenian, you don't have that letter there. So anyway, good guess. So Vicky was correct in the sense that it was easier than many of the previous ones, because I thought like no one would guess this. Like, who would know that this is in Armenia? But at least two people guessed right. So I'm wrong. Vicky is right. Here is my vote for Vicky and Nobel Peace Prize. I can't vote. I keep forgetting. So the plan for today, we are going to talk about sets, which is another data structure which you have in Python and which is quite useful in certain situations. There is a number of assignments concerning the Bajillion search engine project. There are 3 of them actually, and I think we'll do them in breakout rooms and then discuss the solutions in the main room. There is an optional assignment which I find rather tedious and badly worded, so I had to spend some time figuring out what I actually had to do, and then spending some more time getting it to work. And the problem is that it actually requires the knowledge of object-oriented programming because it employs the syntax for that. So I found it kind of strange to, ask you to do something about it without actually knowing how to do it. I'm not sure we'll actually have the time to do it. Maybe we'll discuss it at a later time. So that's the plan for today. And let's talk about sets. So a set is an unordered, mutable data structure that has an important caveat in that it cannot contain duplicate values. So when we say unordered, it's much like a dictionary. There is no indexation. All the values are, mixed up. So you cannot refer to them by an index. Mutable means that you can change it, add values, remove values. And the fact that it cannot contain duplicate values means just what it says. It means that you can't have two of the same value in a single set. And this is similar to a dictionary in the sense that in a dictionary, you cannot have two keys that are the same, because for purposes of a dictionary, keys are sort of like the values, though they're not. And the same thing applies to sets. And the reason why sets exist, because you could say that's like a very weird and strange data structure, why would you use it? The advantage of using sets is that much like dictionaries, and that's why I brought up dictionaries, they use hash tables for fast access. And you do not have to understand what a hash table is, though I know some of you try to understand it, but that's not that important. The thing is that using hash tables as the underlying mechanic allows you to perform certain actions very quickly with data, as opposed to doing it through a list, for example. And another thing that is interesting is that sets can have, or they do have, unique operators and can have operations performed on them. And we will talk about those operations today. And I hope you'll see how this is useful in the Bajillion project, in the functions that had to be written for the Bajillion project. So first, let's talk about the syntax. So in order to create a set, you use syntax which is somewhat similar to dictionaries. Sets are also created using the curly brackets, and inside the curly brackets you have the values separated by commas. And you might ask, well, how does Python understand that this is a set and not a dictionary? A dictionary has key value pairs. A set just has, a number of values. And this would be a set of strings, like this would be a set of integers. You could have sets with various data types, but the important thing is that all the values must be immutable. So you can have integers, floating points, strings, booleans. You could actually have a tuple as a value in a set, but you cannot have lists, you cannot have dictionaries, and you cannot have other sets. So you cannot have a set of sets. And the reason for that is in order for hash tables to work, you actually need the values to be immutable data types, because otherwise it would not work. Vicky, I saw your raised hand. Do you have a question or a comment?
Yeah, because didn't you say that sets are themselves mutable?
They are mutable. They're not
Right.
immutable. Oh, sorry. You are correct. You're absolutely correct. Something snapped in my mind. So you could have a set of sets, I suppose. You are correct.
Right. And so my question is, if sets
No,
themselves,
wait. You cannot have a set of sets. I was correct initially, because sets are mutable, and you cannot have values that are immutable.
okay, so what I don't understand is if set as a data structure is mutable, correct?
Yes.
Okay, if they are themselves mutable, why would the elements within a set have to be immutable?
Remember, for instance, dictionaries. In dictionaries, all of the keys have to be mutable. So you cannot have a mutable key in a dictionary. Does that ring true? Does that ring a bell?
Wait, so yes, the keys in the dictionary have to be mutable,
Immutable.
immutable.
Yes. The
Okay.
reason for that is, if we get into details, for a hash table to work, you need to have sort of the hash built on the sort of calculated from the value of the key. And
Well,
if you change the key after that because it's mutable, then the entire hash table breaks down because suddenly
well,
it's not
right, right,
pointing to the
right.
current place.
That part I understand. But I thought that lists and dictionaries, because they are mutable, they cannot be be hashed.
What do you mean? Dictionaries are based on hash tables.
Well,
They,
okay.
they, they themselves cannot be keys. A dictionary cannot be a
Correct,
key to
correct,
another dictionary.
correct, correct.
Same thing here. A set cannot be value in a set. Because for a set, the values themselves are sort of like keys in dictionaries, because based on that value, you get the hash value, which allows your set to work.
But are you saying that sets can actually be keys in a dictionary?
No, because sets are mutable, and dictionaries cannot have mutable keys. All keys have to be mutable.
Okay.
So
Okay.
the only data structure that you can have as a key in a dictionary is a tuple. Oh, you can also have the frozen set, but we're not going to discuss frozen sets. That's such a weird data structure. I don't even know why it exists.
Okay.
Yeah.
Yeah, I mean, basically, I think it's just very weird that you have a mutable data structure, but the elements themselves have to be immutable.
I don't know why you think that's weird, but that's the way it is. Once again, the reason for that is that you cannot have a hash table based on mutable values because it screws up the hash table. That's the
I
only reason.
mean, because in my mind, when I think of a data structure as mutable, I think of it as being able to be changed. Like you can add things, you can subtract things,
Yes.
you can change its elements. And so if you change its elements, then then when I conceptually think about it, I don't associate that as an immutable element.
But why does this confuse you in sets but does not confuse you in dictionaries? Or it also confuses you in dictionaries?
Because in a dictionary you can change the value, right?
Yeah, but in a dictionary, like the key in a dictionary is the same thing as the value in a set.
The key in a dictionary is the same as the value in a set.
Yes, so basically a set uses as hash tables with its values as keys.
Okay. Okay. Well, I don't want to waste people's time. You can just go on.
All right, so, but just keep it in mind that the values in a set have to be immutable for it to work. Some might think that this is the way to create an empty set, but it's not. This is the syntax for an empty dictionary. So you cannot just put two curly brackets open and closing and think that this will be an empty set. If you do want an empty set, you call the set function with no parameter. This will return an empty set to you. Now the question is, if you look at this, let's say I want to create a set, and when I'm creating this set, I have a single 1, 2 2s, 3 3s, 4 4s, and 5 5s. What do you think is going to be the result if then I try to print this surprise?
Either
Error.
an error,
That's
or
one.
or it collapses all the repeated values.
Okay, so which one do you think it is?
I think it's
Well,
an error.
I'm with Steve.
I think it collapses it, but I don't know.
It does. It actually does. So the result would be a set with only 5 values. So all the duplicate values will be collapsed into one value. And honestly, there is no guarantee that they will be in this specific order. I think they will be starting from Python 3 point something, much like with dictionaries. But since the data structure is unordered, you shouldn't expect them to come in a specific order because it might be different. Also, you can use the set function to turn a different data structure into a set. For instance, in this case, we can take a list which contains a number, of ones, a couple of twos, and 1 3, turn into a set using the set function, and the set will have only 3 values: a single 1, a single 2, and a single 3. An interesting exercise if you use set on a string. For instance, if we take abracadabra, you would get back a set of letters, each letter being, in the set only once. So it will be a set of, 5 of the word abracadabra, but there will not be any doubles, triples, or what have you. Sets, much like other data structures, have a number of functions and methods that can be used on them. I've included only the most common ones. So you can check the length of a set. You just need to use the len function. It has the add method, which adds an element. Pay attention that it's not append like in a list, because append means stick to the end, but there is no beginning and no end in a set. You just add it somewhere into a set. You just throw it into the bag and it's there. So add will add an element. And you have 2 methods which actually delete elements from a list. The first one is remove, and you will get a key error if this value is missing, if it's not present. The second one is called discard, and discard will not give you an error if it's missing. So depending on whether you actually want to get an error or not, in case there is no such element, you can use either remove or discard very much on your program and what you're using this set for. And now let's talk about some operations which are unique to sets, and in some cases they give you a very interesting and fast way to solve some problems or some issues that would take longer with other data structures. The first one, so sets. The first one is 1 2 3 4. The second one is 3 4 5 6. The first operation that we're going to discuss is called the union operation. These operations are between 2 sets. The union operation, the operator itself, is this vertical, what's it called, pipe, I think in English. So you say like set 1, union set 2. And what union does is actually take all the values from the first one, from the second one, and combine them or unite them into a single set. So in our case, we have 1 2 3 4 5 6. So that would be the result of the union of these 2 sets. Of course, no doubles. The second operation that you have uses the ampersand character, and this one is called intersection. And you can guess from the name that the intersection shows you the values which are present in both sets. So this is where they intersect. In our case, they intersected the values 3 and 4 because these 2 values are present in both sets. The third one is called difference, and the order matters because you take, in this example, you take the first set, 1, 2, 3, 4, and you sort of subtract the values from the second set, which are present in the first one. So you would subtract the 3, you would subtract the 4, and only 1 and 2 would be remaining. So here is a question to you guys. Let's say we want to do difference the other way around. Set 2, difference set 1. What would be the result in this case? What would be the values in this case?
5, 6.
Exactly. It would be 5, 6, because you would take 3, 4, 5, 6, then subtract 3, 4, and only 5, 6 would be remaining. That is absolutely correct. Nancy, you are correct as well. So that's much like in mathematics, the order of the operands matters when you have to subtract, or in this case, find the difference. But there is also an operator which is called symmetric difference, which does it both ways. So in this case, the symmetric difference of set 1 is set 2 is anything that doesn't intersect. So it's the direct opposite of intersection. So that would be the result of 1, 2, 5, and 6. And if you know this, oh, hold on, can you explain why set 2 minus set 1 is 5, 6? Okay, sure. Let me do this one more time. So set 2 has the values 3, 4, 5, 6. So now we have to remove any values that are present both in set 1 and set 2. So I'm subtracting the values from which are present in set 1 from the values which are in set 2. So 3 is present in set 1, so I destroy the 3. 4 is present in set 1, so I destroy the 4. 1 and 2 are not present, so I ignore them. And what's remaining is 5, 6. So I get rid of whatever is doubled, and whatever remains is the difference. I hope that makes sense.
Why do you ignore ones that are not present?
Because you
you're
can
ignoring ones.
subtract them. There is nothing to subtract them from. You're
Okay.
basically saying remove from set 2 anything that you also have in set 1.
Okay.
And yes, Dieter, thank you for the image, because that's what I was getting to. You can actually visualize this, and you can visualize this using so-called Venn diagrams. So let's take a look at these two sets as circles. As you can see, the circle on the left is set 1, it has 1, 2, 3, 4, and the circle on the left is set 2, it has 3, 4, 5, 6. And you can actually visualize each of these 4 operators or operations by coloring certain parts of the circle. So for instance, if you talk about union, that means coloring both circles entirely. So unity means taking everything that's inside the two sets, regardless of whether it intersects or not. On the other hand, if you look at intersection, that's exactly what it means. Intersection is the piece that's between the two sets. So that's, you see this way why it's 3, 4. If you talk about difference, you would actually say, okay, this is set 1, and from set 1, I want to delete anything that's in set 2. So that's why 3 and 4 are discarded and only 1, 2 remains. If you flip the two operands and you have set 2 minus set 1, it goes the other way around. You get rid of the 3 and 4, and only 5 and 6 remain. So I hope this makes it easier to understand why it's the way it is. And the symmetric difference is actually, like I said, it's the opposite of intersection. So everything that doesn't intersect is the result of the symmetric difference. So that's a very good way to visualize sets and how they have these operations applied to them. And before we go on into the assignments, are there any questions or comments on sets? Maybe there are some things that I need to go through again, anything that's unclear. And I would repeat that these operations, the operations between sets, are very fast. So they are done at lightning speeds compared how similar things would be done with a list, thanks to the hash table mechanics which are used for them. And I would actually urge you, even if you've completed this assignment without using sets, I would urge you to actually think how these assignments could be done by using sets, because they would actually make it simpler. So one more time, sets are really fast because they use hash tables. This has nothing to do with references. Hash tables as a mechanic is a very fast, they provide fast lookup. Without going into details, which would require some time, for instance, if you take a list, let's say you have a list of 100,000 values, and you try to find out whether a value exists in this list, how many operations on average do you need to take before you find that value, or you say, no, this value doesn't exist in the list? If it's 100,000 values.
You have to look through all of them.
Well, or at least you find it.
Yes.
At least until you find it. So at the worst, exactly, it's going to be 100,000. On average, it's going to be more than 50,000, because there will be cases when they're not present and you have to go through all of them. Hash tables actually allow you to do this a lot quicker, because they do not go like check first value, check second value, check third value, and that 100,000. They use an algorithm which is similar to dictionaries, because dictionaries also use hash tables. They look for the value based on a certain hash function, which returns you the answer, whether it's there or not, a lot quicker than just going through all the values. And this is as much as I could probably say without going into details of how hash tables work in general, because it's sort of a separate topic and it's a bit advanced and it requires some time to get into it. So I don't know whether this explanation is enough, but that's the way it is. Any other questions, thought, commentaries on sets? Well, if anything comes up, just shout out or type out, whichever way you prefer. So let's talk about the assignment, which is called the Bajillion Search Engine Assignment, and it has a number of sub-assignments. So let's take a look at them one by one. The first assignment asks us to implement a helper function, which is called common. It takes in two lists, which are called list 1 and list 2. They are given as parameters. And this function has to return a list of elements which are present in both of those lists, with the only caveat being that if there are several identical elements present, the final list should have only one such element. You do not have to include all of the elements. If you have, if you apply this function to these two lists, the first is 1, 2, 3, and the second one is 3, 4, 1, there are only two values which are present in both lists, so the result, the returned list, should be 1, 3. The following two lists, A, B, C, and B, D, F, B, B is the only value which is common to both of them, and even despite the fact that there are two B's in the second list, it doesn't matter. If you have at least one match, you need only one value in the final list, so it should be a list of one value B. And the third one, which the two lists which do not have any elements in common, should return an empty list. So can you make a list from a set? Yes, you can actually make a list from a set and a set from a list using either the list the list function or the set function. So the set function turns anything into a set, the list function turns anything into a list. So you can basically do it back and forth, and this way you can get rid of doubles. So yeah, but that's a good question, Martha. You're already thinking, you know, in the correct direction, because now that I've told you about sets, the solution to this assignment should be pretty self-explanatory, because it basically says, hey, use a list here. This is like the best way to do it, instead, you know, of comparing values one to another. So I'm actually thinking right now whether for this specific assignment we actually need to go into breakout rooms. Maybe this one we can discuss here online, I mean in the main room, and then just go to the next assignment. Yeah, I also think that there is no need. So can someone help me out here? Share and go into VS Code. Let me share my VS Code now. And here is like the common placeholder. So we need to implement this function here. So any ideas on how we could do it? Okay, so we can get set 1, we can get set 2 from the two lists, and then return, oh wow. Well, Vicky, you're doing the list comprehension, but we do not need a list comprehension in here. I mean, we could it could be done like this, obviously. So that's
I was
a
just using
solution.
it for practice because I like totally
Good,
forgotten
good.
how to do it.
Right, you wanted to refresh list comprehension, so that's good. And this would work. But then with sets, let's go, yeah, so let's say set 1 is set for list 1. Set 2 is set for list 2. And then we just need to return their intersection, which is the ampersand. Set 1 and set 2. But the only thing we need to do, we need to return a list back. Remember, according to the description, it has to be a list. So this is like three lines of code, which we can actually collapse into one line of code. We can take this and put it here. We can take this and put it here. And in the end, it turns out that this is a one-line function. So once again, we are returning the intersection between the set from the first list and the set from the second list turned back list. Yes, for sorting. Sorting is not required. Sorting is not required in the sense that obviously the doc tests that we have here think that we're not using sets. The doc tests think that we're using lists to do this. So that's why they assume that it's going to be in a specific order. For sets, since we cannot guess what the order is going to be, you would need to return sorted or sort the list. So instead of list here, you could do sorted like this if you are adamant about passing all the doc tests. But in this specific case, I think the doc tests actually mislead you, because nowhere does it say that the new list has to be sorted in any way. So this is one of the ways it would look like. But if it returns C, comma A, it would still be sort of fulfilling the condition that's described here. It test, but in this specific case, the test is not, etched in stone. So let's run this, and we will see that we get A, C, empty, and A, which corresponds to the doc tests we're expected to get here. But even if we remove sorted and just do list, The only difference is this one. So we're going to have CA instead of AC, but like I said, in my opinion, that's not important for this specific function. It doesn't say anywhere that it has to be sorted. Can you do, let me look at the questions. Can you do set comprehension using the list comprehension syntax? I believe you can, yes. I think you could have set comprehensions the same way as you could have list comprehensions, as you can have dictionary comprehensions. Like we discussed, the only thing that does not exist in Python is tuple comprehensions. So, and I see that you're saying that there is like the idiotic, long, laborious way of doing it, but it's actually the way I think that CS 106 expected you to do it without knowing sets. And that's the reason why I sort of looked at this and said, it's a lot faster to do this a different way than through iterating over lists one after another. Your question is, why can't you have tuple comprehensions? The reason for that is simply because it doesn't exist. If your question is, why doesn't it exist, then I suppose that there is no reason to, I don't know, I have no clue. I just know that that syntax is reserved for generator comprehensions. I guess there must be a reason why they decided that, oh, okay, no, I think I know why. Because a generator comprehension will give you basically the same thing as tuple comprehension without storing all that stuff in memory. And since that's a better way of doing it, it's always better to have something, not have something in memory than have it in memory. There is no reason to have both. The reason I'm seeing that you're talking about in some cases it fails, in some cases it passes. The reason for that is probably, once again, that sets are not ordered. You cannot expect a certain order to a set. So in some cases you would have passed tests, and in some cases you wouldn't. But this is a situation where you have to look at this smartly and not just be, blinded by the test result, but actually realize why this result is, correct or incorrect. So I wouldn't worry about it too much. Okay, so I think we're done with this one. This one, as you can see with sets, was pretty simple. So let's talk about the next two assignments. These two we're going to do in breakout rooms. Let me return to my presentation. And so the next assignments are like this. The first function that we need to implement is called create index. This function will take as the first parameter, it will take a list of file names. So there will be one or more file names in a list. And then you will have two dictionaries, which will actually be empty. So you just need to create two empty dictionaries and pass them in as parameters. The one is called index. The second one is called file titles. And the task of the function is to go through the files, through the entirety of the files in the list, and do the following. The first thing it needs to do is update the index dictionary in the following way. The dictionary has to, as its keys, it has to have the terms which are mentioned in the files. And the word terms is a more generic term, I'm sorry to say, for words. So any words that you have, or any numbers that you have, or anything that you have in those files separated by white space could be terms. And these terms have to be keys. More importantly, these keys have to be lowercase, regardless of how they're present in the file. And you have to remove any punctuation which is at the beginning or at the end of each term. If there is some punctuation inside, in the middle of the term, it has to remain. And these are keys, and for values for each of these keys, you have to have a list of file names that contain these terms. So this is harder to understand by listening than looking at an example, which we will do on the next slide. But first, let's talk about the second thing that we need to do. We also need to update the file titles dictionary so that it contains file names as keys and the first lines of those files as values. So it's sort of the header of the file. For each file, you have to store the header of that file as a string, as a value, and the key should be the file name itself. But let's look at dictionaries because, at examples. Let's say we are printing some index, some file titles. And let's say we had two files which are called unimaginatively file1.txt and file2.txt. And the first file has hello world and the second file has goodbye world. So for index, your result would be the following. You would have a dictionary. For keys, you would have the terms. So inside these two files, you have three terms. You have the term hello, you have the term goodbye, and you have the term world. The term hello is only in the first file, so it's a list of one string, file1.txt. The term goodbye is only in the second file, so it has a list also of the second file as the value. The term world, however, is in both files, so as a value it would have a list of both file names, so both file1.txt and file2.txt. So that would be the end result of your function updating the index dictionary. The second one for file titles, it's simpler. You would have the key file1.txt and you would have hello world as the title. So that's the first line of the file. And then you would have file2.txt as the second key and you would have goodbye world. And note, this is important, if you compare the terms inside the files themselves with the terms which are stored in the index dictionary, you will see that though hello and goodbye are capitalized, they are lowercase here. Also note that the comma and the exclamation mark are also removed because punctuation marks have to be removed, so they're nowhere here. So this is important because this is these are two to meet, and that's the first function that we have to do. So one more time, that's the function create index, and unless there are some questions on this specific task, I would propose to go into breakout rooms and work on them. Once again, specifically, if you've done this, we'll have one room for you. If you haven't, we'll have another room for you. And even if you've done it, think about how you could do this using sets instead of whatever you've used before. Share my screen. Let me share my screen. And common elements does not interest us anymore. We're in the search engine file. And let's see at how this could be done. Like, once again, this is not the best solution. This is not the only solution because there are tons of ways you could do this. But let's discuss some of the actually interesting things that we discussed in the complete room when we looked at the solutions. So once again, just as a reminder, we have a list of file names. We have to go across each of these files and fill two dictionaries. Indexes, the index has to have terms as keys and file names, a list of file names as values, and file titles is a lot simpler. You just have to have the file name as the key and the title, which is the first line, a string as the value. So obviously we will need to go through all the files. So we can go for file name in file names. But here is an interesting story. If you take a look at one of the tests, you will see that we have a test which has the same file name repeated twice. And then you sort of go, so do we actually want to read the same file twice? Is that like productive? And the answer would be no, not really. How can we work around this? Well, we can use a set. So instead of writing simply for file name and file names, we could go for file name and set names, because we don't care in which order we go through the files, but we do care, save some time, because if we had the same file name like listed 20 times, would we actually open the file 20 times? No, probably not. So this was one of the first great ideas that I heard from the guys in the group. Now that we're inside the file, the question is, do we want to first go through the entire file and fill the index and then open the file again and read the titles, or can we actually do this, in one go? And my thinking is it's better to do it in one go to avoid opening, closing, then opening the file again. So we are specifically interested in the first line. So let's create a variable which is going to be called first line. Of course, first we need to open the file. So we're going to go with open file name. We can include encoding just in case, not necessary, but good practice. Let's call it as file. And now we're going to have first line equals file read line. Remember, we need to strip any extra /n's at the end, so we don't want the new line. And now that we have the first line, there are going to be two things that we're going to be doing with it. The first thing that we're going to do, we're going to take our file titles dictionary. We're going to use the name of the file as the key, and we're going to save the first line as the value. So we're basically done with the part which deals with the second dictionary for this specific file. But now we also have to parse this first line for terms. Now let me quickly look into the chat. Do you have to convert to lowercase as well for the index? Yes. Yeah, we'll get to that. So we do not want to convert for the title, for the file titles, but we do want to convert for the index. So the second thing that we're going to do is I'm going to create a subfunction, and that's what most of the guys did as well. Let's call it, I don't know, parse line, and I'm going to parse the first line. I'm going to first line, and I'm going to add the index into which we're parsing. So somewhere here, I'm going to have parse line, first line index. For now, I'm going just to leave it empty. And then I'm going to go through the rest of the line. So I'm going to go for line in file. So starting from the second line, I'm basically going to do the same. I'm going to say parse line index. Yeah, and here I'm just going to call it line. And notice that I do not need to return anything. So I saw some examples where people wrote return index file title. This is not necessary for the simple we're given these as parameters, and whatever changes we do inside the function will persist outside the function because dictionaries are mutable data types. So this is completely unnecessary. We do not need to return anything. So now the thing that we need to do is actually parse parse each line. So the way we're going to do this, first we need to also strip it. Then we need to turn it into lowercase to remove all the capital letters. And we can actually split it here into terms. So I don't need a line, I would actually have terms. So this is a list of terms now. The next thing I'm going to do is I'm going to go term by term. So I'm going to say for term in terms. And the only thing I'm thinking right now, I would need the file name here as well. So I would pass the file name as the third parameter. Is it file name? Yes, file name. Like this. And for each of the terms, the first thing I'm going to do is check whether the term is already a key in the index or not. So I'm going to say if term in index, if the term is not in the index, if it doesn't exist yet, I need to create it. So I would need to go index term, and for now it would be an empty list, so there are no files for the terms yet. And after this, what I'm going to do is index term append the file name we just got, like this. And we're going to repeat this on a loop for each of the term in the entire list of terms that we got here, and add items if it's necessary. Yeah, this as well. And I think we should be good to go here, but I could be wrong. So
punctuation is something
punctuation. Thank you. Yes, punctuation. I just saw the dark string here, and I'm not using string. I need to be using string. So we're going to lower. Then I'm going to strip string punctuation, yeah, and only then I'm going to split. So I'm doing this in one long line. Okay, let me try testing this. Let me import doc test, and then somewhere here, let's do doc test mod, and run and see what we get. Okay, we have failures.
Alex, can I ask you a question about your line 74?
Yeah, just give me a second. I'm wondering whether the issues we have is because of order or file to title ball caret. Okay, we still have the exclamation mark for some reasons here.
We need to move the strip punctuation inside the loop for the individual terms. Otherwise, it will just strip from the line, beginning and end.
Okay, true. Because lower applies to everything, but strip applies to only to the end of the entire line. So yes, thank you. I would then go for if it's term in terms, I would probably go term equals something like this, so that I don't do it 3 times. Let me try this again, and I think this time it works. I can't understand. Yeah, this time it's good. Vicky, shoot your question.
Yeah, okay. So I had a question about line 74, initially as the way you wrote it. Okay, and so your terms is basically a line, right? Okay.
My terms here is going to be a list of strings.
Right, but those strings are lines from your file, right?
Yes,
Okay.
yes.
So can you just clarify okay. Okay, I know what split is doing. Split is like separating each word, and I know what lowercase is doing. Okay. Um, but I was a little bit confused as to what you are stripping here. Are you actually stripping the punctuation in the beginning and the end, or are you stripping white spaces? Because why did you need strip here and also strip the string punctuations? It seems like you're doing two different stripping steps, and I'm just not sure what you're stripping here.
The reason is I'm not sure whether the new
Oh,
line
got it.
character
Okay.
is
Okay.
punctuation or not.
Gotcha. Okay.
Maybe it
Yeah, yeah, yeah.
is,
Okay.
and then I don't need this. But we could actually check. This is easy to check because maybe you're
That's
right.
fine. I
Yeah, it
understand
seems it
that.
is. It seems it is.
Yeah.
So that was
Okay.
the only reason I did it. But we can remove it without any problem. So any other questions or comments on the code that we have here? That's not clear, or maybe something like Alex, nicely done, but I have some better ideas. And let me quickly check the.
But going back to, sorry, what Vicky was just saying, I don't see where the strip is done.
Now it's
Uh,
done here.
okay, okay. Ah,
So
got it.
punctuation, it seems, also takes care of the new line
Got
character.
it. Okay, so that includes the carriage return. Got it.
Yeah, it
Thank
seems
you.
it considers that to be punctuation as well. I didn't know, so
I think the getting rid of the new lines actually happens from the split, right? Not from the.
No, split does not.
Yeah, it splits on new lines on any white space. I think I looked it up. And white
Ah,
space is spaces as well as new lines.
that's actually true. Now that you say it, the split would get rid of the carriage return at the end of the new line symbol at the end. You are correct. Yes. So that also would be a reason why we wouldn't need a strip here. Yeah. So thanks for pointing that out. Okay, Mansi, I see that you're saying understood now. What is UTF-8 and why do you have to specify it? Okay, so this is a quick answer. UTF-8 is one of the Unicode encodings used to represent different languages that we have. And for the English language, it's not strictly necessary because the English language being, the language of the world, was the initial language which was used, and it's the basics of ASCII tables. But if you go into other languages that use other alphabets, like the Cyrillic alphabet, I don't know, Arabic, anything from any languages from India, like from Asia, Chinese, Korean, Japanese, anything, it would be outside of the regular ASCII table. And if you do not include this, then Python will incorrectly parse that language. Although, if I am not mistaken, starting with Python 3.14, which is the newest one, this is done by default. So they finally realized that having the UTF-8 encoding by default is the way to go, because previously that was not the case, and you had to actually show this, and I'm still doing it through habit. I'm not even sure whether I have 14. I don't think I have 14. Does it matter if the files themselves are encoded in UTF-8 or something else? Yes, of course it does matter. So if they're encoded in something else, you would need to use another encoding, but by default, multi-language files or files with languages other than ones using the Latin alphabet will be encoded by this one. So this is sort of agreed upon default right now.
Wait, Alex, I thought that if you were to include UTF-8, okay, it actually converts it into UTF-8 so that Python can understand it.
It doesn't convert the file itself. It just tells Python that this is the encoding that you should read it in. So it basically tells Python how to, what's the word? How to interpret the bits that are being read from the file. So from the file, you're basically getting zeros and ones, and Python needs to understand what those zeros and ones mean depending on the encoding that is being used.
So, so I guess in other words, if you have a file in Cyrillic, and then even if you were to include encoding UTF-8, it still wouldn't read it correctly.
Yes, so if it's a different Cyrillic encoding, then you would get an incorrect reading, because there are a number of Cyrillic encodings which are different from UTF-8. Like older ones, which were used like 20 years ago, 10 years ago, I don't know.
Okay. But if you have like a Chinese file, and then if you use UTF-8, it's still not gonna read it correctly, right?
No, it should. Like, I think the Chinese symbol, I'm not an expert in Chinese encodings. Probably 20 years ago, you also had a number of different Chinese encodings. But if the file is saved as UTF-8, which is done by default, for instance, if you save a text file in Windows, and probably on Mac as well, then it would read correctly. So it would interpret those bits correctly as Chinese hieroglyphics. All right? I think I've answered all the questions in the chat. So shall we then maybe look at the final one? Let me stop my share here and open my presentation again, and look at the final function that we need to implement. And the final function that we need to implement is called search, and this is basically the function that performs the search. It takes in two parameters. The first one is the index which has been previously created, so the result of using the previous function. So remember, it has terms as keys and lists of file names as values. And then you get a string, which is a query. So basically what term or terms you're looking for. And you need to return a list of file names that contain all of the terms in the query. So if it's more than one term in the query separated by spaces, all of these terms have to be present in order for you to add that file name to the list. So let's look at an example. Remember our world and goodbye world example. So let's say that we wanted to look for hello world, whether hello and world are present in any one file, and it will return to you a list with this string. So this would mean that both hello and world are present only in file 1. So it will not add file 2 here. If you do the same with goodbye world, you would get a list with only file 2. But if you would search only for the term world, it would return a list of 2 files, because this term is present both in file 1 and file 2. If you search for something which is not present anywhere, you would get an empty list. So if this term is nowhere to be found, an empty list is returned. And any questions on this one before we go into breakout rooms again? I think then we can open up the rooms again, spend maybe 15 minutes in them, and then spend the last 10 minutes actually solving this. Yeah, I think so. Everyone is back. So we only have 4 minutes left, and I have to finish on time today, which will make Vicky happy, I suppose.
No,
But let's.
I was gonna say you can go over today, but
Okay. Unfortunately, I can't. So let me open.
you can roll it until next week if you want.
No, no, no. I mean, I want to go through this solution. Can you see my screen now?
Yeah.
Okay, cool. So, once again, we had a nice discussion in our breakout room. I hope you guys and gals also had an interesting discussion in your rooms. Just for the sake of not wasting any time, I'll sort of put together all the thoughts that we had. So basically, we have an index, which is a dictionary we got from the previous function, and a query that we need to apply to it. And the first thing we need to do is to separate the query into separate terms. So the way I'm going to do it is say terms equals query.split. And as it turns out, remember, we figured out that we do not need to do the strip because the split will take care of the strip. So we can only do split without the strip. Now, the next thing we're going to do is going to go through the terms one by one in a loop. So I'm going to go for term in terms. And the first thing I'm going to check if this term is actually present in the index as a key, because if it's not, that means that there is no match. There is 0 matches. There are no files that contain this term, and we just need to return an empty set. So I'm going to write if term not in index. This means we're done searching. We don't need to check the other terms because we already have at least one missing. So in this case, I will return an empty list. Otherwise, what I will do is actually create a, it's initially going to be a set, an empty set. Let's call it files. I'm going to do it an empty set. And what I'm going to do is one of two things. So at this point, I know that the term is in the index, because if it weren't, I would return already. So I could say if not files, which means if the set is empty at the moment. So if the set is empty, in this case, I'm just going to turn it into a set with whatever's saved under that term in the index. So the list of file names which this specific term has, because it's the first one. There are no terms in there yet, so I'm setting this to be the first one. And the reason why I do this is that so this doesn't fail, because if I remove this one, if I get rid of this one will fail because files is not set. Otherwise, what I could do is use a set operation, and the set operation is going to be, let me try to get this correct, it's going to be the files and an intersection of what I have as a set in index term. So basically the idea is that I take the current files, which supposedly has a number of files. I take the files that this specific term is mentioned in, and the intersection means that I take the lesser of the two. So whatever was there before and whatever is this term is present, and this will find the intersection between these two Venn diagrams, so to say, give me either a smaller subset or the same set if the terms intersect fully. And basically, after I do this for each term, I would be able to return files. The only thing, if I remember correctly, it has to be a list. have to return list files. Maybe I made some mistake somewhere because I'm doing it in a bit of a hurry, but let's test for it and see whether this actually works. Let's do doc test test mod and see what it tells me. No, it actually works. So the only thing I would look at here is I do not like this construct. In my opinion, this construct is too verbose, too large. We can actually make this smaller by using comprehension. So what I would do, instead of these four, I could write this in one line and say files equal set index term if not files, else files and set index term. So basically I squeezed these four lines into this one line. This is a comprehension, a set comprehension, and this will do the same thing as these four. I would check just to make sure I didn't make any mistakes, but it seems it's working. So we can basically delete this, and as you can see, this is done in 7 lines in this specific example. Like once I said before, not saying that this is the only way and this is the best way, but in terms of brevity, I think it's a pretty good option, especially given that we discussed comprehensions during our previous meeting. So this is a good place to use a set comprehension and to actually understand that set comprehensions can also be employed. So any questions, comments? Yes, Anna, I see you saying this looks neat and clean, and I'm one of those guys who likes it neat and clean, so thank you for noticing. I think I understand why union and intersection of sets would make this task easier. Good, because yeah, I think that's the power of sets. It gives you an instrument to find intersections, put things together. If you do not care about repetition of values, if you do not care about the order of the values, then sets are a very good instrument. And once again, I'm surprised that CS106 did not include, for some reason, sets, because I think it's also a very important data structure, but with a narrower area of usage. I like the method of doing it one way and then this is actually this is something that I often do. First you write it one way and then you think I can sort of make this shorter, I can refine this, and you do it again, and I think it's a very good exercise to do this. Set comprehension with ternary operator. Yes, that's the one. So this is, yes, remember we discussed that this is actually, this this comprehension does not have the conditional clause because we're using a ternary operator inside the expression itself. So there is no if something at the end, no condition. Next class, setting them up for next class, yes, and that's actually what we discuss next time we meet. We're going to discuss classes and objects and object-oriented programming, so nice pun. Unless there are some questions that you have, I will bow out now, but I'm sure that even, if there are questions, maybe Dieter and Vicky can help me out. I need to go attend to the little one. So thank you very much for being here with us today. And I look forward to seeing you again in our next session, object-oriented programming. It's going to be difficult, but it's going to be fun. So see you next time, guys. Bye-bye.